Is rate of change. Rate of change is a ratio. And before we even go on, what's a ratio? What's a ratio? We've already talked about that in this school year. When you hear the word ratio, what should you visualize in the mathematical world? What does it look like? A fraction. It looks like a fraction. So what's happening in a fraction? We have a numerator and we have a denominator. So a ratio is a comparison of two things. So in our ratio, in our rate of change, this ratio is going to compare the amount of change. How much change is there in a dependent variable? And we have talked about dependent variables. Dependent variable being which one? Is it the x value or the y?
Y.
It's the y. The dependent variable is the y. It's what our function rule is set equal to. It is dependent upon what happens in the function rule, where the x is located. So our dependent variable we typically call the y value. So the amount that the y value changes to the amount of change in an independent variable. Well, if y is our dependent variable, that leaves x to be our independent variable. And this change of the dependent variable to the independent variable is over a specified interval. So when we're talking about rate of change, we're usually talking about from a certain point to another point, a specified interval. Okay, this is where our book is going to come in. We're going to go to the check it out at the bottom of page 244. You should have probably already done this in your SQ3R. So let's see how it went for you. Okay? So at the bottom of page 244, we're going to do the check it out problem. You should have already studied example 1 when you were SQ3Ring. So we'll go directly to the bottom of the page, number 1. The table shows the balance of a bank account on different days of the month. Find the rate of change for each time interval and then figure out during which time interval did the balance decrease at the greatest rate. How many time intervals are there in that table? How many time intervals can we set up?
5.
5? Okay, give me an example of one of them, Aaron.
Would be like 6 over 285 minus 1 over 550.
Okay, let's just talk about time over a specified interval. Let's just talk about time. Let's just leave the money out of it right now. So what could be one time interval?
5 days.
5 days, from day 1 to day 6, right? Or from day 6 to day 1, doesn't matter which way you look at it. Okay, so either way, there's a time interval right there. From day 1 to day 6, an interval of 5 days. Okay, give me another example of a time interval in that table.
10 days.
Pardon?
10 days.
10 days, and which one's that one then, John?
6 to 16.
Yeah, from day 6 to day 16, we can have another time interval. So now tell me, how many time intervals, how many specified intervals can we set up from that table? Can we get 5?
4.
Let's just talk about 4 of them. Let's go from day 1 to day 6, from day 6 to day 16, from day 16 to day 22, and from day 22 to day 30. So we have 4 specified intervals, 4 rates of change we should be able to find in this situation. Okay, well, when you're doing these, though, you always have to decide what's going to be, you're going to have to pick. They're not going to tell you which one's the dependent variable and which one's the independent variable. So if you remember remember back to when we were talking about rates and unit rates, remember I said we always want to decide how should it be set up. Do we talk about, typically, let's use something like traveling in a car. We just got out to the holidays and some of you have probably done some traveling. Do your parents calculate how many miles they got per gallon of gasoline, or do they calculate how many gallons of gasoline they use per mile? What's the typical way?
Miles per gasoline.
Miles per gallon of gasoline. So upstairs in the rate would be, the miles would be represented, and downstairs would be the gallons. So you would get miles per gallon. Okay, so we always have to decide what would be the way, a good way to set this up. So what would make more sense here? Would we want to show the days per dollar or dollars per day?
dollars per day.
Yeah, dollars per day. So that would mean the dollars are upstairs and the days are downstairs. And it says right up here in our definition that you do the change in the dependent variable, that's what would be upstairs, over the change in the independent variable, that's what would be downstairs. So our dependent variable is going to be the bank balance. We'll just call it balance here. The dollars. And the independent variable then will be the number of days, so that we end up with dollars per day. Makes more sense to talk about how much the bank balance changed in dollars per day than days per dollar. So you first of all have to make that decision. Which one's going to be the dependent variable, which one's going to be the independent variable, so that you get a rate of change that even makes sense, okay? So for day one, from day 1 to day 6, we're going to put, it says we're going to do the bank balance upstairs. Typically what I like to do in the table is I like to work with, so that I'm going to be working with positives. So how could we set up, what should we subtract upstairs for the first interval that we talked about, from day 1 to day 6? What do you think we should set up for our subtraction problem upstairs so that we'd end up with a positive number? Should we take 550 and subtract 285, or 285 and subtract 550? Really? You left your brains behind in 2015? Okay, so which would give us a positive value? Taking 550 and subtracting 285, or taking 285 and subtracting 550?
550 minus 285.
Why, thank you. Wow, that was painful. 550, take away 285. The change in the dependent variable, we're doing this first interval from day 1 to day 6. Well, now we have to keep that order though. So if we started with day 1's balance upstairs, we have to use day 1 downstairs when we take the days now and do their subtraction problem. So 550 take away 285 over 1 take away 6. The change in the bank balance over the change in the number of days. So what does 550 take away 285?
265.
Yeah, 265 over 1 take away 6.
-5.
Negative 5. So what happens here? What do we end up with? What's 265 divided by a negative 5? What was the change as a unit rate now? When we divide this out, we're changing it into a unit rate of change. Okay, so how many times is 5 going to 265? How many?
15.
53, yeah. And that's a negative 53, right? Because a positive divided by a negative is a negative. And it's dollars per, oopsie, do that, dollars per day. So it went down an average of $53 a day. The bank balance decreased about $53 a day. Doesn't mean it had to do that exactly every day, but as an average, that's what happened, because it had 550 at the beginning, went down to 285 over a 5-day period. Okay? Okay, what would the setup be for day 6 to day 16 then? What would we have upstairs? Brendan, what would be our subtraction problem upstairs?
285 minus 210.
Okay. Sage, what would be our subtraction problem downstairs?
It'll be 6 minus 16.
6 take away 16. Okay. So we have 285 take away 210. Class, what's that?
75.
Oh,
60.
6. How about 75?
Yeah, so
Negative 75, isn't it? 75 plus 10, 285? Or 85, I mean, 75. Okay. What's 6 take away 16?
Minus
Negative 10, okay? So 75 divided by negative 10.
-7.5.
-7.5, and we're talking about money, so we could say a negative $7.50 per day, right? It went down an average of $7.50 per day over that time interval. Notice the intervals don't have to be the same length in time. We're just showing what happens over each interval, whether they're equal length or not. That does not matter. Okay, day 16 to day 22. Caden, what would be our subtraction problem upstairs for that one? Okay. To day 22.
minus 210.
Okay, so that's how much was in the account on both days. Okay, what would our subtraction problem be downstairs? Candace?
16 minus 22.
16 minus 22, okay. Okay, so 210 take away 210, well, 0. There was no change in the balance, but there still was a change in the time period. What was the time period? -6. Okay, what's 0 divided by -6? 0. So it's $0 per day. The change was $0 each day. Average in, anyway. Okay, and the last one. Riley, what would be the subtraction problem upstairs for the last one, day 22 to day 30? 210, take away 175, okay? Cameron, what's the subtraction problem downstairs? 22 take away 30, okay? 210 take away 175 is? 35. And 22 take away 30 is? -8. And this isn't going to divide out quite as nicely, but we're still going to divide it out and just show it as it is. What would this one be?
4.3.
4.3. Let's even leave it as a half a cent. That's okay. So was it 37.5 cents?
Yeah.
0.375. Okay. It's okay to leave it like that because it does terminate, and sometimes banks do actually, work with half cents at a long time, but then at the end, of course, they can't give you a half a penny. But showing the average rate of change, we could say it's $4.37.5. That's really what this is per day. Is it going up or down though? Is it positive or negative? It's negative. We can't forget that negative sign again, showing that it is decreasing that much each day, not increasing. We didn't have to worry about a negative sign in the last one because of the 0. Okay, so now we have found the 4 rates of change that this table gave us. So the other thing we're supposed to find is over which interval did the balance decrease at the greatest rate. So from which day to which day is the bank balance going down the most?
Day 6, or 1 to 6.
Day 1 to day 6. At the beginning of it, day 1 to day 6, the bank balance actually decreased the most. Okay, as I've been saying all along, and it's really important that we understand, if we were to graph this, we would not have a straight line, would we? No, because each of those is a different rate of change. It's not a constant rate of change. So when we don't have a constant rate of change, each rate is actually representing an average change each day during that particular interval. So it could have been more than that one day, it could have been less than that one day, but when you average it all together during that time period, it's actually giving you an average change. And so the actual change may have been different on a daily basis. when we give the rate of change over the whole interval, we're actually giving an average rate of change. Okay, so this one would not be constant. When we connected them on a graph, we should have a zigzag line. We shouldn't have a straight line. Okay, any questions on rate of change? I very seldom get questions, but when I ask you guys to perform on these, it doesn't go well. How'd you do in your SQ3Rs on this? Did your SQ3R match this? Did you get the same rates of change?
Except I turned it positive.
Somehow yours turned out positive? Yeah. And sometimes what we want to do is when we're setting up subtraction problems, we want to set it up so that the upstairs and the downstairs are both going to be positive, so we don't have to work with negatives. But you have to make sure, that's a really important point, you have to make sure that if you're representing day one's bank balance upstairs first, then you have to have day one represented downstairs first also. Order matters in these. And so that's possibly why that happened. You thought, I'll just do 6 take away 1, 16 take away 6, right? Okay. Anything else that you're noticing happened when you did it on your own? Okay, then let's go to the back and start talking about slope then. What's slope? It's a rate of change. What kind of rate of change?
From the run of any two positions. It's the ratio of rise to run from any 2 points.
Okay, the ratio of rise to run from any 2 points. Okay, if we have a line that we're going to talk about its slope, what would have to be true about the rates of change over any interval on that line?
Did that be the same?
Have to be the same. So we're going to talk about slope being a constant rate of change. When the rate of change is constant and it's a non-vertical line, we are really talking about the slope of it. And when we're looking for the slope of a line that's non-vertical, we can do it by using any 2 points on the line. You can use 2 points that are towards the beginning of the line and really close to each other, or you can take points from either, like kind of opposite ends of it, and it shouldn't matter because the rate of change over any interval on there is the same, it's constant, so you should be able to find slope using any 2 points on that line. So slope is just like our rate of change in dependent variable over change in independent variable. Again, this is where lots of times students mix up. You have to have the dependent variable represented upstairs, the independent variable represented downstairs. So that change in dependent variable would be a change in what again then? Which variable? Y over the change in X. And another way they talk about change in Y, because remember Y is the vertical, is the rise. Change in X is the horizontal, we call that run. Rise over run. So you will oftentimes hear slope referred to as, instead of change in X, change in Y over change in X, or change in dependent variable over change in independent variable, they'll just say rise over run. Okay, so, and slope is going to be something that you're going to have to always be able to identify. So, when we have positive slope, what happens from left to right? What's the behavior of the line? What's it doing? It increases or rises, let's use that as a little bit shorter word, rises from left to right. So as you're looking across the page from left to right, as you would read across the page, that line is going up, it's rising. Or in other words, what happens to the y values as you're going from left to right? As your x values are increasing, what's happening to the y values?
They're increasing.
They're also increasing. So y values increase from left to right. As x is increasing, so does y. Okay, what happens when we have negative slope then? What kind of behavior is there? It's decreasing, or let's use a shorter word, it falls from left to right. So as you're looking across from left to right, that line is going down instead of going up, right? And what's happening to the y values then? They are decreasing. The y values decrease from left to right. So as x is getting bigger, the y's are getting smaller. Okay, what kind of a line has zero slope?
Straight.
What's that straight line called that goes like this?
No correlation.
Well, not really, well,
Unidentified.
no.
Zero undefined.
Okay, what kind of a line is it? What's its behavior?
It's always gonna have the
Like
same.
what's- you guys- Well, when it's going straight across from left to right, what kind of a line is that called? Horizontal. We have a horizontal line. Its behavior is horizontal. It's not rising, it's not falling. It's going from left to right, straight across the page in a horizontal fashion. And what's happening to the y values? As x is increasing, as you move from left to right, what's happening to the y's? Are they increasing?
No, that's yes.
Are they decreasing? They stay the same, so there's no change, yeah. Y values have no change from left to right. They will always be the same. For every point on that line, the y values will be the same. So if y is equal to 2 for one of the points, y will be equal to 2 for all the other points on that line. Only the x values change. Okay, what kind of behavior has what kind of line has an undefined slope? What kind of line goes straight up and down? A vertical line. So when we have a vertical line, we have an undefined slope. It's really important that right now here you understand undefined does not mean the same thing as zero. Zero slope means as you move from left to right across the page, across the line, the y values do not have any change at all. They stay the same. Undefined does not mean the same thing. What does not happen with a vertical line?
It goes horizontal.
Does it go horizontal?
No, that's right.
Yeah. So there is no left to right. So in other words, we can't talk about the x values controlling anything because there is no left to right. Our independent variable is not changing, it's not controlling anything, so there is no left to right, there is no, we talk about there being no slope and undefined slope. So zero slope does not mean the same thing as undefined slope. You have to be able to talk about them differently and understand what each of them means. So slope is a measure of the line's steepness. Anybody go snow skiing over break? Anybody get to hit the slopes? No? Darn. Anybody ever get to go snow skiing? Yeah? So,
Skied in the water one time.
okay. And when you ski in the water, typically, is there any slope?
No.
There's zero slope, right?
Well,
You're just going.
The waves.
Well,
Oh.
yeah, if you go up, yeah, if you're brave enough to,
I skied behind
Jump
a
away,
horse
I guess.
this weekend.
you what?
When you go down.
I was trying to stop the horse because he's running away from me because I couldn't catch him, and I grabbed him by his tail and he kept going. And I slid.
Oh, so you had some snow skiing going on there, didn't you?
Yeah.
But it was horizontal skiing.
I went up a kind of.
Oh, there was a bit of an embankment there for you to go up? Okay.
It was flat.
Well,
So-
I go down.
It was cool.
When I go to the slopes to snow ski, I pick the ones that are less steep than probably you pick. I'm gonna guess you like the ones that have some pretty good, you're gonna go down pretty fast. Me, I like the ones that are not as steep and I can make sure I'm not gonna break a leg. So when we talk about steepness, I oftentimes think of like the slopes of when you're out snow skiing rather than water skiing. Okay. So as the absolute value of the slope, what do I mean by absolute value again?
Distance from.
Distance from zero. So as the absolute value of slope, that would mean we're talking about its distance from zero, which is always going to be a positive value or zero. It can't ever be negative. So when we talk about the absolute value, as the absolute value of slope increases, the line becomes what? What happens as the absolute value gets of the slope? It's bigger. What happens to the line, to the slope of the line?
Increases.
It increases. What does that mean?
Then
Yes.
Steeper.
Steeper, yeah. So those slopes that I don't want to hit, they have a slope that's a whole lot bigger, its absolute value is a whole lot larger than the ones I like to hit. So tell me, which line would be steeper? A line with a slope of -3 or a line with a slope of 2?
-3.
Why -3?
Because it's absolute values.
Right.
Because its absolute value is right?
No,
that's a good
Three.
It would actually be 2.
No,
Just trying to be difficult on
No, I think it'd be 2.
Why? Yeah, go ahead and.
Because, like, it'd be closer, so it would be a smaller triangle. I'm thinking of, like, you go up like a mountain. So, like, 2 here is negative, and 2 here is positive. Like, if you have, like, -3, it'd be like this.
It should flatten it out some more, you're thinking.
Yeah.
Because it's got what, longer distance, so on a triangle it couldn't get to the corners as fast?
it's an equilateral triangle, so, no.
Huh.
It's just killing.
Well, what do you think? Who's right?
I think that,
I think John's
beyond it would be.
What does it say here? It says, as the absolute value of the slope increases, the line becomes steeper. So let's write this down. Absolute value of -3, gotta get my negative
It's
sign in
3.
there, is what? 3.
Right.
And the absolute value of 2 is
Obviously 2.
2. And when we make a comparison of those two, which one's larger? 3 is greater than 2.
So Kip was right.
So who's right?
John and Sage are definitely.
Kim.
So it says, so therefore, okay, let's write this out in our notes. Therefore, 3 is greater than 2. The absolute value of -3 is 3. The absolute value of 2 is 2. 3 is greater than 2. It says, as the absolute value of slope increases, the line becomes steeper. So we're going to say, therefore, the line with a slope of -3 is steeper than the line with slope of 2. So it has nothing to do with one of them has a positive slope and the other one has a negative slope. Which one has a larger absolute value? That's going to be the one that's going to be steeper. Okay? And it would be nice if we could, say in a triangle situation that yes, that one's got more distance to cover, but that isn't how the steepness is calculated. It is by forming, the triangle that you're talking about. Does it have to be equilateral? Does it have to be isosceles? Who knows? I think we'll find that out though as we start graphing more and going along. And we'll see if maybe, Aaron's theory works out ever. Okay? So, ever. Okay.